an actual aerial photograph of the building after it was completed on the New York City skyline. So quite a shocking element, but a testament to some beautiful design with ceramic tile and architecture. This is a project that just simply shows where the architect originally wanted a combination of a rough-hewn stone and then a colorful ceramic tile facade, and we eventually convinced them that some of the same textures could be realized with porcelain tile. So eventually this became a complete porcelain tile facade, and we were able to provide the architect with the juxtaposition of different colors and textures of tile, all with the same material rather than using stone. Here's an example of ceramic tile, again, used as a building system, in this particular case, a swimming pool. This is in Vancouver, Canada. And the entire interior of the building is tiled. But most important is that the ceramic tile system was conceived as a system and promoted as a system by the manufacturer. So everything, including all of the different drainage components, the water stops, the grates for the trench drains, were all part of the ceramic tile system. So again, the point is that we need the ceramic tile industry to provide us with proven systems, with complete systems, with all of the parts, and then we'll figure out how to use it in exciting ways in architecture. This is a very exciting project in Antigua, where there are no windows on the hotel rooms. And we originally were presented a concrete structure where all of the infinity pools and terraces in the rooms were part of the roof of the hotel room below. So you can imagine how important the ceramic tile system was again. The waterproofing, the adhesives, the expansion joint, how the tile responded to thermal expansion and contraction from the sun. All of these elements had to be taken into consideration in the design. And I don't believe that there's any better natural integration of beautiful material like ceramic tile than there is in this photograph, showing the blend between the infinity pool and the ocean beyond. I always love, even though I could spend an entire hour on this project, I always love showing everyone what the rooms look like. And you can actually arrive at this hotel by helicopter. And you can see right here, during the construction, here's the helipad. And this room is actually right below that opening. So you can land in your helicopter and then drop through that opening into your pool. So, but this is what we really started with here. And there are rooms right below that. And the ceramic tile, in this particular case, both porcelain tile and glass tile had to be conceived as a very important system. So my third prediction, in keeping with the theme of the conference, was sustainable wall systems. And back in 2002, ventilated porcelain tile wall systems were in their infancy, just as computer modeling was, and I predicted that they would be a significant force in the future. So here we are in 2012, and I know for a fact from the type of work that our firm is doing, as well as assisting various manufacturers in importing and designing these systems in the United States, that we've made significant progress to the effect where I think that within 5 years, I guess I'm making another prediction, that within 5 years there's going to be significant demand for those types of systems. There's a great presentation later in the Qualicer program on the sustainability initiatives in the United States and I believe throughout the world. But I thought that I would just highlight one particular one. It's called the Green Squared Initiative that's being promoted and developed by the Tile Council of North America, as well as the American National Standards Committee. And the point that I wanted to make here relative to this dialogue with architects that the industry needs to continue developing is that this new system of Green Squared in the United States for the first time is taking into consideration innovation of products as a measure of their sustainability. And what I'm trying to say is that most architects are familiar with different sustainability requirements like use of recyclable materials or natural materials in products. They understand end-of-life issues with regards to recycling capabilities. They understand energy savings of different products during their manufacture and their transport to the site. But now we're really in the second generation of sustainability. And I believe architects and engineers are now a little bit smarter. And this particular program is having us assess systems based on their innovation, which I think is really important and probably, to me, the true measure of sustainability in architecture. How innovative is the product? And again, as a building system, how does it work to be that holistic, or take on that holistic approach of a sustainable material? And the other thing important note on this is this particular program is being developed in advance of the International Green Construction Code, which will be coming out in early 2012. So we've made significant progress since 2002. We are now really on our second generation of understanding sustainability, and I think now the ceramic tile is leading the way in enabling architects to truly understand how these materials can be used in sustainable architecture. So I call ventilated tile wall systems the ultimate sustainable exterior wall system. And here are some projects. This one is interesting because it actually doesn't use porcelain tile. We wanted to use porcelain tile, but we were working with the architects, international architects, Gensler Associates, on this project. It's a 52-story high-rise project in Los Angeles that was just completed. And we were looking at developing a basket weave type pattern ventilated wall system. And unfortunately, because of the basket weave system, we needed to utilize a thicker porcelain tile slab, a 30-millimeter thick slab. And that is a relatively new technology, and we just simply couldn't get the production on time and in the texture that we needed, so we ultimately had to use Indian sandstone. So somewhat of an opportunity lost, but the point is that ventilated tile systems and stone systems are becoming very popular all over the world. The largest architects in the world are using them now, and in very, very interesting ways. And I think that this basket weave system, and I even saw, even though I didn't attend Sevi Sama, there are also some very interesting shingle or overlapping types of designs that architects are exploring also. Here's a project with a 1200 by 600 12-millimeter thick porcelain tile ventilated system in the UK at Gatwick Airport, a university building. And this is actually my company's facility where we have mock-ups of a lot of different projects that we work on. And I pride myself on being a hands-on technical architect, so we actually build everything and analyze it when we design it. And you can see here, I'll show you in a moment, a review of all of the sustainable benefits of a ceramic tile ventilated wall system. But you can see here that we can just take the walls, lift them up, move them around, look at different patterns, look at different tile designs, as well as have access to the back of the system. So tremendous benefits with the system. And I'll quickly review this. There have been numerous presentations at Qualicer over the years about ventilated tile systems, so I don't intend to go into any detail here today, but just I would like to review some of the sustainable benefits. First and most important is thermal control in these walls. The insulation is placed on the exterior of the wall envelope, or the primary wall envelope. And what it does is it places the insulation at the most efficient location. And that also allows you to control condensation within a wall system. And more importantly, as air flows through the ventilated system, the convection of the air actually insulates or provides additional insulation. Another important factor of thermal control is the tile's ability to act as a thermal and solar screen. So that allows the porcelain tile to absorb and dissipate heat, and most importantly, the tile is not directly in contact with the inner wall, so there's no what is known as a thermal bridge, so the heat does not conduct to the interior of the building. Also, thermal expansion and contraction of the building is isolated in these systems. So there's just numerous benefits, sustainable benefits from these systems as far as thermal control is concerned. Moisture control. Most of you have heard about how ventilated systems are also known as pressure equalized rain screen walls. And what that means is when the wind blows against the facade, the open joints allow there to be an equalized pressure on the internal cavity, and that actually prevents water from bridging that cavity and getting to the internal primary wall beneath. Ventilated system also allows us to put the waterproofing inside the internal cavity and always have access to it. So as far as the insulation and the waterproofing is concerned, it's always accessible for maintenance, for repair, and also in the absolutely ideal position as far as an architect's concern is for designing an exterior wall. Some of the structural efficiencies using porcelain tile. Porcelain tile probably has a greater strength and durability compared to materials that are 2 times as thick. Obviously, prefabrication is significant relative to sustainability simply because there's less waste on the site and things are constructed much more efficiently off-site and assembled on-site. And then as far as maintenance, I already mentioned that the ventilated wall systems allow access to the internal wall cavity to allow you to maintain and repair waterproofing, insulation, and any other mechanical systems or other services that may be within the interior wall cavity. And then lastly, the ventilated tile sitting outboard of the wall acts as an acoustic diaphragm to dissipate sound, and that the insulation being exposed on the inside cavity of the wall also absorbs sound. So very efficient wall from an acoustic perspective also. The most important aspect, though, to this presentation about the dialogue with architects as the key to the future are the potential future innovations. And some of the ones that we're exploring and working on, and even at our lunch yesterday, we were debating the merits of some of these ideas. They're just very exciting to me, some of which are already in use. The first is tile surface technologies are already on the market. Self-cleaning, hygroscopic, antimicrobial coatings and glazes are a significant improvement over other facade cladding materials. So that adds additional sustainable benefits to ventilated wall systems. Then we start getting into very interesting innovations. For example, laminated polymer films for strength and safety. We now require, and building codes require, that the backside of ventilated porcelain tiles be laminated with a safety film to prevent breakage in the same way laminated glass is protected from breakage for safety purposes. But most of you have probably seen very thin 3mm porcelain slabs now. They're actually laminated between a polymer film to create a thicker composite porcelain tile that has significantly greater strength due to the polymer film lamination as well as safety. So these are very significant improvements for ventilated porcelain tile wall systems. It gets more exciting as we go up the list. Laminated photovoltaic films. There's already been research done right here in Spain, and this is a photograph of photovoltaic films being laminated to porcelain tile. The key is as an industry, we need to figure out how to combine the beauty of porcelain tile and hide the photovoltaic films, because this technology is already in use in the glass industry, and we will be left behind if we don't figure out how to incorporate photovoltaic films into ventilated tile facades. And in a moment, I'll show you a photograph of one of the first photovoltaic glass facades. And lastly, most exciting, are liquid crystal films, already in use again in the glass industry. We need to find a way to be able to laminate liquid crystal films to the surface of porcelain tile with clear glazes that will allow porcelain tile to change colors, to display video. That technology is already in use in the glass industry. And one advantage is that glass is clear. And this, unfortunately, is a photo taken from the internet, so it's not very clear, but it is one of the first glass ventilated photovoltaic facades. So we have the same potential for innovation in the ceramic tile industry. And I would, as an architect, love to work with anyone who is involved in these types of innovations. Last, I would like to address installation pathologies. And in 2002, I basically said that the industry has not been devoting enough resources and paying attention to installation pathologies. And many of you that have been coming to Qualicer Congress over the years realize that every year there are multiple presentations on installation pathologies, adhesion failure, efflorescence. Unfortunately, Since 2002, this is the one prediction that I made where there's been relatively little progress towards solving those problems. And again, the industry as a whole has to devote resources to this problem and can't just say, we manufacture tile, you, Mr. Architect, you, Mr. Contractor, you're responsible for how it gets used, and we don't want to have anything to do with it. You know, that's a naive position because you're only, as we say in the United States, shooting yourself in the foot. We're only ruining our own industry if we don't pay attention to this. And here's the ugly truth. You've seen this in many, many presentations at Qualicer over the years. Gross efflorescence dripping down the face of buildings. In the United States, there really hasn't been much change in this, and most architects say, I won't specify an adhered ceramic tile facade because they see these pictures and problems all the time. And most manufacturers of ceramic tile products and installation products really haven't done a good job to address this problem. We just don't want buildings that look like this. So I'll just leave you with the thought and show you some examples of what we've been doing over the last 10 years to solve the problem. And we believe that we've solved the problem, but it really shouldn't be a voluntary type of approach. It really should be a mandatory type of approach. This is a small ceramic tile facade that we're currently designing. But even in a small building like this, we looked very carefully at the details here. Most of the adhered ceramic tile facades now also ventilate the cavity a little bit. So we're using drainage mats now. 5 minutes. We're using drainage mats now also to allow water to drain, and even doing things like this. We're keeping the tile off of, in this case, the concrete-based wall to allow the water to drain. So we have weep holes coming out through this drainage mat that allow water to drain through it. And then very careful metal flashing that protects surfaces to prevent water from working its way back up through capillary action. So these are simple, important details, and they're no longer voluntary. They really need to be mandatory in order for these systems to work. And this is just a quick photograph of a few of the different types of products that we use as drainage mats. Here's a project in southern Florida in the United States where we use these drainage mats. There's no efflorescence whatsoever on the project at all. And the reason I show this photograph is this is a completely exposed, direct adhered porcelain tile facade. So it's exposed on 4 sides. There's multiple potential points for entry of water, but there's no efflorescence whatsoever. And we very carefully designed areas for at the junction of different types of tile where water can drain out from the system from the drainage mats. And lastly, I'm just going to show you a project that's actually 20 years old right now and still no problems, and I've shown this at Qualicer over the years, but it's a close-up showing how even back 20 years ago we were using waterproof membranes, and in this case there is an expansion joint that actually acts as a water drainage channel. And this project is perfect 20 years later, no efflorescence, no problems, but it used mandatory, or what I like to call mandatory components as a full system that act together to prevent the types of pathologies that I just showed you. And this is a photograph of that building in all its beauty reflected off the water. So I'd like to conclude my presentation in the spirit of the conference theme, Green is Growing. I'd like to offer what I call my prayer, architect's prayer for sustainability. And most of you have probably heard of the phrase, form follows function. And it couldn't be a more important phrase today with the importance of sustainability in architecture. And this phrase, most of you may not know where it comes from. It's actually 115 years old. And the phrase was coined by famous American architect Louis Sullivan in 1896. And this is an excerpt from his book on steel high-rise construction, and Louis Sullivan was considered the father of steel frame high-rise construction. And the prayer goes like this: "It is the pervading law of all things organic and inorganic, of all things physical and metaphysical, of all things human and all things superhuman, of all true manifestations of the head, of the heart, of the soul, that life is recognizable in its expression, that form ever follows function, that is the law." So that's a perfect expression of how important sustainability is in architecture today. And the concept of form follows function and the expression of biological importance couldn't be more important today. So I thank you for your attention. Gracias por su atención.
Se inicia el coloquio. Si alguno de ustedes quiere hacerle alguna pregunta al conferenciante, por favor, es el momento. Bueno, en la mesa hay una de las personas que quiere hacer una pregunta.
Well, first of all, I congratulate you on your presentation. I like it very much. I'm so curious. I have so many questions to make. But as we can not take that time, so I'd like to know something more about the finite element method he used to analyze the behavior of a facade under stress. So, can you make some comments on how do you consider the elasticity models of the tile, its size and the thickness? Because I have already seen on a late edition of Qualicer that the size and the thickness of each layer has additive mortar, and if you have a previous coat like a cement render, it changes a lot the generation of the stress and the elasticity modulus of the layers you put together. So how do you consider that? This is the first question. The second question I would ask, how do you know this is accurate? Did you test a prototype, or are you measuring the real stress that occurs on the building facade? So how can we trust on it?
Okay, those are both great questions and long questions. So the first question deals with the effects. So I make sure I understand that the effects of tile size and thickness and all of the components in the system on predicting the behavior. And it's absolutely true that the computer modeling shows that there are significant additional or significant greater stresses as tile sizes increase. And computer technology also shows that increases to a point where once a tile gets to a certain size, it doesn't really make a difference any longer. And in the reverse, it also shows that small tiles have very negligible buildup of stresses. In that, the Alhambra Tower that I showed you, the computer actually showed that there were negligible stresses in the, not negligible, but much lower stresses in the adhesion of the tile as a result of the grout area. It was a Trencadis style tile, and the actual amount of grout area was significant and provided a cushion so that stresses didn't build up from tile to tile. So the components in the system, the size, the physical characteristics definitely have a significant effect, as does other components. We did an analysis of thickness of adhesive